If for the same problem I try to look at the current angle, I can see that the impedance was XL was 75.4 ohms, XC was 2652.51 ohms, and of course R was 1 kilo ohms, that is 1000 ohms. Now in order to find the impedance angle, if we draw the impedance diagram, this one is R XL, so in Cartesian coordinate this is XL and this is the imaginary axis, plus J minus J, and this one is XC. So XC was much bigger, so ultimately the resultant X is somewhere there, so angle will be somewhere there, like that. Resultant X will be somewhere there, so angle will be somewhere there, approximately, if we draw it to scale. So the angle will be, of course, this is the angle, which will essentially be this one, which is XC minus XL. In this case the angle will be negative, of course, because it's going counterclockwise. So XC minus XL, if we just try to find the angle, XC minus XL over R and tan inverse of that, and the angle will be negative. So if we do this calculation, we end up getting XL minus XC is something like, I don't know whether the calculation is correct, but just double check, should be 1000. So 2573.11, that's the subtraction, this one minus this one, this one minus this one, and then the angle is becoming, after doing tan inverse, it's becoming approximately 68.79 degree. So this is the angle. So the impedance was, as the magnitude of impedance was, as I did before, 2764.33, and with the angle this is negative 68.79. Of course it will be negative because we can see that this one is, if had XL been greater than XC, the angle would it would be somewhere here and the angle would be positive. So the current, once we try to find the current, I will erase this part. Current is again now with the angle, current, the maximum current again, so Vm over Z, now the full Z, which is with the angle, so I'm just writing Z, it will be 150 over 2764.33 minus 68.79 degree. Now this current we calculated in the last video, so this one was 54 milliampere, and the angle, as we can see, since this is in the denominator and this one is actually 0 degree, so angle is becoming 68, angle is becoming something like 54 milliampere is the amplitude, angle is becoming 68.79 degree, because once I do the subtraction, this is 0 minus of 68, so getting a positive angle. And this is the thing, that since this current, in this circuit, the capacitive reactance is more than the inductive reactance, so the circuit overall is capacitive, and because it's capacitive, the current is leading. We can see the current angle is leading because the voltage angle was 0 degree and the current angle is 68.79 degree. And of course if we needed to find the RMS value, it's just nothing but the, so RMS current is, if I say I, which would be Im over this one, similarly V would be Vm over square root 2. So that's how we find RMS, of course. So it's just the extension of the previous problem to find the angle